Good morning, students. Now we are going to see the topic called wire cut electrode discharge machining, which is called WCEDM. Now, this is the schematic diagram of a WCEDM. Control circuit, servo circuits, wire drums, electrode wires, power source, working table, and there is an x-axis and y-axis of the movement. Okay. Now we will see the construction of the wire cut electrode discharge machining process, which is called WCEDM. A very thin wire 0.02 to 0.3 mm made of brass or molybdenum having circular cross section is used as a electrode tool. The wire is stretched and moved between two rollers. The part of wire is eroded by spark. The prominent features of moving wire is that a complicated cutout can easily machine without using an electrode. It consists of a workpiece movement control unit, workpiece mounting table, wire drive section for accurate moving the wire at constant tension, dielectric fluid supply unit, power supply unit. Now we will see the working of a wire cut EDM process. This is another one schematic diagram, how it's operated. This is the dielectric fluid which sprays on the workpiece and the wire. Now we will see the working principle. Workpiece to be machined is mounted on the table, which is operated by control unit. A very small hole is pre-drilled in the workpiece, through which a very thin wire made of brass or molybdenum is passed as shown, and this wire is operated by the wire feed mechanism. Dielectric fluid, distilled water, is passed over the workpiece and the wire tool by using pump. When the DC supply is given to the circuit, spark is produced across the gap between wire and the workpiece. When the voltage across the gap becomes sufficiently larger, the high power spark is produced. This spark occurs in an interval of 10 to 30 microseconds and with a current density of 15 to 500 amps per mm square approximately. So thousands of spark discharge occurs per second across the very small gap between the wire and the workpiece, which results in increasing temperature of about 10,000 degrees Celsius. At this high pressure and temperature, workpiece metal is melted, eroded, and some of its vaporized. The metal is thus removed in this way from workpiece. The removed fine material particles are carried away by dielectric fluid circulated around it. Now you will see the features and advantages of WCEDM. Manufacturing electrodes. In this process, a very thin wire made of brass or molybdenum is used as a electrode tool to machine the workpiece material. So there is no need for manufacturing electrode as in EDM, which are traditionally made by current and grinding by using an expensive alloy of steel, silver and tungsten. These features used to reduce the man-hour requirements and ensures greater economy. Electrode wear. During machining process, the wire electrode tool is constantly fed into the workpiece. So the wear of tool is practically ignored. Surface finishing. A very thin wire electrode is constantly fed into the workpiece at speed of about 10 to 30 mm per second by wire feed mechanism as shown in figure. So machining is continued without any accumulation of chips and gases. It gives high surface finish and reduces the manual finishing operating time. Complicated shapes. By using program, complicated and very minute shaped can be efficiently machined. So there is no need of skilled operator. Time utilization. Since all the machine motion of wire cut EDM process are controlled by NC, it can be operated throughout the day without any fire hazards. Straight holes. The electrode wire is maintained at optimum tension by a unique wire tension control mechanism. So it is prevents taper holes, barrel shaped holes, wire breakage and wire vibration. Rejections. Rejection of material is minimized due to initial planning and checking the program. Economical. Since most of the programming can be easily done, it is economically for small batch production, including production types. Cycle time. Cycle time for die manufacture is shorter as the whole work is done on one machine. Inspection time. Inspection time for wire cut EDM process is reduced due to single piece construction of dies with high position accuracy. Disadvantages. Capital cost is high. Cutting rate is slow. It is not suitable for large workpiece. Applications. The wire cut EDM process is best suited for the production of gears, tools, dies, rotors, turbine blades, and cams for small to medium size batch productions. Difference between electrical discharge machining and wire cut electrical discharge machining. Wire cut electrical discharge machining. Very thin wire made of brass or molybdenum is used as a electrode, which is called tool. In EDM, expensive alloy of silver and tungsten are used as a electrode tool, which are traditionally made by cutting and grinding. Second point, the whole workpiece is not submerged in dielectric medium. Instead, the working zone alone is supplied with a coaxial jet of dielectric medium. The whole workpiece is submerged in a dielectric medium in EDM. Third point, it is easily to machine complex two-dimensional profiles. In wire EDM, it is difficult to cut complex two-dimensional profiles. Recent development in EDM process. Electrical discharge machine changes from using relaxation circuit to faster and more efficient impulse circuit. Instead of using copper or as electrode, ordered tungsten copper is preferred.